Welcome to The Explainer. Today, we're going to crack open the powerful and, let's be honest, kind of fascinating world of machine learning.
You know, it all starts with a question we bump into pretty much every single day. How do our devices and apps seem to know exactly what we want, sometimes even before we do?
Well, the answer in just 2 words is machine learning. And really, the best way to wrap your head around it is to think of it as a problem solver's toolkit. So for the rest of this explainer, we're going to unpack that toolkit together, piece by piece.
So when you pop open this toolbox, the very first big decision you have to make is all about the kind of problem you're trying to solve. And that decision, it all comes down to the data you've got to work with.
Think of it like 2 main drawers in a big cabinet. In the first drawer, we've got supervised learning. Here you have an answer key. Your data is all neatly labeled with the correct answers, so the machine can learn from really clear examples. But in the second drawer, unsupervised learning, there is no answer key. The machine is on its own, and its job is to find the hidden structures and patterns all by itself. Honestly, this is the single most important distinction in all of machine learning.
So let's start with that first drawer, supervised learning. This is your world when you have a guide, that trusty answer key, to help your model figure things out. Now, even within this drawer, you have to ask another question. Is your goal to put something into a specific category? You know, a classic example is deciding if an email is spam or not spam. It's a clear yes or no kind of choice. If the answer is yes, then congratulations, you're doing what's called classification, and you've got some fantastic tools at your disposal. Naive Bayes is a classic. It's super fast and just perfect for that spam filtering problem. But for higher accuracy or on more complicated problems, you might reach for a real powerhouse, like a random forest.
Okay, but what if you're not predicting a category? What if your goal is to predict a specific continuous number? You know, something like the price of a house next year or the temperature tomorrow afternoon.
That, my friends, is called regression. The simplest tool in this part of the box is linear regression, which basically tries to fit a straight line to your data. But for more complex, real-world relationships, that same random forest model we just mentioned has a regressor version that can handle all those tricky, nonlinear patterns.
All right, let's close that supervised drawer and move on to the next one, unsupervised learning. And remember, the big rule here is we have no answer key. We're asking the machine to go exploring and find interesting patterns for us.
A really common task here is trying to find natural groups in your data. For a business, this could mean finding different segments of customers who behave in similar ways, even if you had no idea those segments even existed before. This is called clustering. A famous tool for this is K-means, where you actually tell it how many groups, or K, you expect to find. Another one, dbScan, is really fascinating because it finds clusters based on how dense the data points are, which means it can discover groups of pretty much any shape. Now, what's so cool about this unsupervised toolkit is that it can find these totally unexpected relationships. This is where the legendary beer and diapers story comes from. A model was analyzing grocery store data and found that these 2 items were bought together way more often than anyone thought. So stores started putting them closer together. That right there is the power of finding hidden connections. Okay, now that we've covered the basics, let's get to the heavy machinery, the power tools. This is where we start talking about deep learning, which is really the engine behind the whole AI revolution we're seeing right now. It all starts with something called neural networks. The basic version, an MLP, is great for your standard structured data. But then they started to specialize. CNNs evolved to become absolute masters of understanding images by scanning them with these little filters. And then RNNs developed a kind of memory, which made them perfect for sequential things like sentences or audio clips. This evolution eventually led to the modern titans of text that you've probably heard of, BERT and GPT. So here's the crucial difference. Think of BERT as the reader. It looks at a whole sentence all at once to deeply understand its context. That makes it amazing for things like search. GPT, on the other hand, is the writer. It works just like we do, left to right, predicting the very next word. And that's exactly why it's the foundation for chatbots and all kinds of text generation. So just remember, reader versus writer, that's the key. And this brings us right to generative AI. It sounds like magic, but it's actually built on the concepts we just talked about. At its core, it's basically supervised learning on an absolutely unimaginable scale. Those large language models, or LLMs, they're just massive versions of GPT, the writer. And those cool image generators like Stable Diffusion, they've learned the supervised task of removing noise from a picture to create a new one. The goal isn't to classify something that already exists. The goal is to create something totally new. Okay, we've seen all the tools, from the basic wrenches all the way up to the AI-powered drills. But where do you actually use them? Well, the final step is choosing your workshop, or what we call a framework.
So how do you choose? It really just comes down to a few simple questions. First one, can all your data fit on a single computer? And you know what? For a surprisingly large number of real-world problems, the answer is yes.
If the answer is yes, your go-to workshop is Scikit-learn. It's easy to get started with, it's incredibly complete, and it has almost all of those traditional models we just talked about. It really is the perfect place to start.
But what if your data is just enormous? I mean, think billions of rows, way too big for any single computer. The kind of data that big tech companies are dealing with every day.
In that case, you need a different kind of workshop. You're going to need PySpark. It's designed from the ground up to distribute the work across a whole cluster of machines, which makes it possible to train models on those absolutely massive datasets. And for our last scenario, what if you're working with those really complex data types we mentioned earlier? You know, images, audio, or the kind of heavy-duty text processing that you need for those big generative AI models.
For that kind of work, you need the specialized high-performance workshops for deep learning, PyTorch or TensorFlow. These are the frameworks that give you the really fine-grained control you need to build and train those complex neural network architectures like CNNs and transformers.
So there you have it. We've laid out the entire toolkit, from figuring out if you have an answer key, to picking a classification or a clustering tool, all the way to choosing the right workshop for the job. You officially have the map. So the only question left is, what problem are you going to solve first?